calculating reliability savings for presentation to a plant manager. Selling the benefits of a reliability program needs to be a big part of the average week for maintenance managers, reliability engineers, techs, craftsmen, planners, supervisors. It just needs to be a big part of what you do because it's so important to the organization. Reliability has an exceptional business case, yet most avoid the selling piece of it. And I've got this question from a Kelly that said we just have a hard time selling the calculations for the savings. So I thought I'd make this video. As a former plant manager, I need to tell you that the reliability case, the calculations you're using for projected savings is far more credible than what your peers are providing from quality, from safety, environmental, and even production. There's a lot more fuzz and optimism in their plans than what you have in your plans based on science and best practices. This is Joe Kuhn of Lean Driven Reliability. Again, this topic comes from a question from Kelly. Appreciate that. So why is it that the quality manager can have great confidence providing a plan for 2020 or 2021 when they believe that it only has a 60% probability of happening, while the reliability teams they can't commit to something that they have 95% confidence in? Why is that? Well, my take, it comes down to the psyche of the individuals. Take a look at quality for a second here. They're comfortable with risk. Many plants, they're putting out millions and millions of parts. And if it's few parts, like, let's say a coil of aluminum, what I'm used to, there's a lot of footage inside of a coil, millions and millions of feet in a coil that make a can. So all the potential for defects can overwhelm you. So you're either going to be in an insane asylum or you're going to get very comfortable with risk. And you're going to tend to be an optimist that coil or that part is good. Does that make sense? The same thing goes for safety. If you sat in your office as a safety leader and tried to calculate or capture on a whiteboard all the ways somebody can get killed today, maimed, or just injured, it will overwhelm you. So you tend to be an optimist or you shy away from that profession. And I'm telling you, these folks are selling me plans that have optimism in it, and I know that. But the reliability and maintenance community shies away from that. Why is that? I think maintenance teams tend to be perfectionists. You balance a shaft to the tolerance. First time, every time. Not just on Wednesdays. You do it all the time. It's how you were trained. This is great for precision maintenance. The second thing in maintenance and reliability circles, you tend to only get bad news. Nobody comes up to you on a Monday and said, hey, the equipment ran great this weekend. They only tell you, this broke, not the 99 things that went great. So you tend to be a little guarded and defensive. And it drives pessimism. Sorry, I'm having a little trouble with words here this evening. And what can go wrong mindset. So, contrast this with the safety and quality individuals I spoke of before. They tend to be optimistic. Maintenance people tend to be pessimistic. What can go wrong? And as such, what tends to happen is, let's just do what we've always done. Let's not try any new technology, no new practices. If we try a new practice, say like PDM, we're going to add that on to our existing PM program and have our same number of standby mechanics and electricians just to play prevent defense. Makes sense? So, 90% odds of hitting a plan, which the maintenance and reliability best practices and tools can get you that level of confidence that you're going to get the results that you're looking for. Those are great odds given to a plant manager based on sound engineering principles and established best practices. So how about a couple examples? Put some numbers to this that you can use. Motors. Our historical spend is $2 million a year. Our KPIs, our vendor feedback of trouble that we send our motors out outside the plant, and our craft feedback, along with our chalk circle observations, reveal that we have poor lube practices and high contamination issues. Contaminations from carbon dust and from alumina entering the motors. So we've determined that. Motors is going to be one of our 3 focus areas this year. And we believe we can cut that by 10%, which 10% of $2,200,000. Okay, we're going to use ultrasonic greasing. We're going to seal up our junction boxes. We're going to do some work with air filtration to keep the motors a little cleaner. We really think we can get 20%, but we promise 10%. Under promise, over deliver, right? I came from Star Trek, Scotty. A little Star Trek reference there. And $200,000 is enough to get anybody's attention. So there's an example of what you can do with motors. On wrench time, hey, chalk circle puts us at 15% wrench time. 2 actions below, we expect to get to 25% wrench time. Really, we expect to get to 30, but we're sandbagging a little bit with 25. So we're going to add a kit or stager. From existing headcount, even though our backlog is growing, we're going to add a kit or stager because the overall wrench time will increase. We're also going to work with our planners to change expectations to anticipate wrench time detractors, and we're going to back off schedule compliance. We're beating them to death with schedule compliance, so they make their schedules easy to get done, which makes wrench time lower. So we're going to back off on schedule compliance. I'm going to ask the plant manager for a little bit of a waiver there. Wrench time is the goal in 2020. We expect $500,000 in savings from this, from contractor spend and not replacing attrition. The math says it's going to be $1 million, but we're only going in with $500,000. Example number 3, circulating water pump. Historical spend is $120,000 a year on these circulating water pumps that we typically have 2 fail a year, about $60,000 per event. We implemented PDM, and we found an anomaly. We shut the pump down, took it out of service, plan scheduled, kitted that job. We fixed it for $3,000. So we're going to, going forward, we're going to promise 57,000 net savings, 60 minus 3, and prevent one of those events per year. We really think we can get 2 events per year using PDM out there, but we're only going to commit to half of that, which is a meaningful number. The reason I think you can sandbag a little bit is these numbers are so big that they will already impress, and you can commit to them and over deliver in the end. Folks, these are based on science. Your peers are selling long shots, and the other people coming in and presenting their plan to me, they're not even a tenth of the confidence level in them based on the scientific practices, engineering best practices that you want to put in place. I have a lot more confidence in the reliability and maintenance team if you'd stand up and sell. This is not a leap of faith. It's a leap of science. Begin your journey, folks. This stuff really isn't that hard. If I can help in any way, drop me an email, drop me a comment to this. I will respond to that. I make many videos based on your comments. If I can help you out, I promise you I can save years off your deployment based on my years of experience. Thank you.